Hey guys, welcome back to another episode of Dev Diary. I'm Leo, and I'm going to show you another item here that I finished creating for this prototype. So, in the last couple of videos or so, I showed you some of the mission system I've been working on. That stuff has taken up a lot of my time, but I decided to take a break from that and work on polishing up the character controller. Just because the character controller has some base functionality doesn't mean we can't go in, polish some stuff, and make it even better, which we always can do. So, let me show you here what I've got. So if I play an editor, look around my little test environment, and when I used to walk, it was just basically a straight shot. The character would just walk in whatever direction I was looking at, and wouldn't really have an organic feel to it. Now if I walk around, you'll notice that there is some head bob that happens. It's pretty subtle, but if you walk down a corridor you can see it, which is pretty cool. Now if you remember, in a previous video I set up this character so that the character could walk, crouch, and walk, so call it a crouch walk. And also the character has the ability to run or sprint, if you want to call it that, which is pretty cool as well. Now, the cool thing about that is if I walk, I have a certain amount of head bob. If I crouch, a head bob changes based on the crouch. And if I sprint, you notice that the head bob speeds up. So it's pretty much trying to simulate the way if your character's running really fast, their head's going to move really fast around, so you'll get a lot more head bob. And this is really cool because it gives a more organic feel to the player, especially when the player's moving, going up and down staircases, feels more organic. Walking down corridors feels more organic. The fact that the head bob can change based on the speed of the character, whether the character's walking or running or crouch walking or anything like that, is pretty cool. What's also neat is that if I bump up against a wall and try to move, there'll be no head bob because I'm really not moving. I'm kind of hitting the wall, so there's no head bob. So there's only head bob when the character's actually physically moving, not when you actually tell the character to move, which is a little bit more of a complex and more advanced setup. But I went ahead and did it just because I thought it would work out a lot better. So cool. So let me show you a little behind the scenes. Not a step-by-step tutorial on how to do it, but I'll give you an overview of how I did it and the approach that I took. When it comes to head bobbing for a first-person game like this one, there's probably 10 different ways you can do it. You can do procedural head bobbing, you can animate your head bobbing, you can do lots of different things. So I sat down before I did this and I kind of thought to myself, well, there's about 10 or 20 different ways to approach like a first-person character head bobbing movement. But the main things that I was concerned with was the head bobbing had to feel organic. So initially I wanted to go with a more procedural approach where I used some math to get the first-person player camera to kind of move around. So if I go to the first-person blueprint and I go to my viewport, this is the player camera. So this is the thing that we want to move around to create that simulation of head bob. So there's a few ways that we can do it, right? We can perhaps create a timeline in Blueprint. So you can maybe go to the event graph and maybe create a timeline that has some animation to it, right? And then you can play that animation when you're moving and stuff like that. You could also theoretically use some simple math and tell Blueprint, hey, when the character's moving based on the amount of speed that they're moving at, go ahead and move the camera around procedurally, maybe left and right or up and down or a combination of those things between a couple of points, right? So you could create a point for the head bob on the right and the left, and then have it kind of interpolate and move between those points. And that's certainly valid. You can use that approach if you want to. Nothing wrong with doing that, so that's another way that you could do this. Another way to do it would be to, if you had an actual first-person like character skeletal mesh, you can animate it inside of a program like, say, Maya or 3ds Max or whatever. You can import that animation into Unreal 4, and then you can attach this camera to the head bone of the character. So when the character's moving, the camera moves with the head during a walk cycle or a run cycle, or maybe like a slow, sneaky walking, crouch cycle. And then you'll get some movement in the camera, and that's a very organic, natural feeling head bob. The downside with that is you don't have a ton of control besides the actual animation, but because the camera is attached to a head bone, that isn't always the best way to do it, unless you sit down and you make a perfect animation for this, which certainly, again, is valid. You could do that if you want to. I took a different approach. What I ended up doing was I ended up using animation to get this done, but not by animating the skeletal mesh. I figured that was a lot of extra work. Maybe later on I might switch to that method. I don't know. This is very, very early in the prototyping stage. So what I want to do is I want to get some head bobbing up and running quickly, easily, but I also want it to be pretty flexible too. I don't want to just hack something together that I'm going to end up throwing away, and I wasted a couple of nights setting this up, essentially to throw it away later. Didn't want to do that. So what I ended up doing was the current iteration of head bobbing. So I can show you now how that works. If I go to my event graph, the first thing you want to do is you want to be able to detect if the player is moving, right? Not if the player is hitting the move key or using the joystick to move, but if the player is actually physically moving in the world, right? So how would you be able to tell if a player is moving in the world? Well, you could use some simple math and calculate the player's velocity or speed in the world, because the player is essentially this capsule, right? And it moves around in the world based on your input from the keyboard or a gamepad or something like that. Sorry about that. That was my cell phone. I will mute that. Should have muted my cell phone before I started recording. I always do that, but I forgot this time. I probably shouldn't stay up working on Unreal 4 till 3 in the morning every day. That's not helping with memory. Okay, so like I was saying, the player moves this capsule around using a keyboard or a gamepad, and as that capsule moves around, Unreal has the ability to track that movement, so we're able to get information from that capsule. For example, is the capsule moving? And if it is, what speed or velocity is it moving at? And we can use that information to further create more complex or more interesting mechanics or logic workflow, right? So if I go back to my event graph, what you're going to see is, here, let me show you, where is that stuff? Over here. So this stuff right here that I'm highlighting, this input axis move forward, input axis move right, this forward vector, this right vector, this add movement input and add movement input up here, that's the stuff that comes already with this player character in Unreal by default, if you're using the first person template, which we are for this prototype. It just makes sense, right? We're making a first person game. So we use that. However, the rest of this stuff is stuff that I created myself, and I'll show you how this stuff works. So there are a couple of functions going on here. The first function is called isPlayerMoving, and if I dig into this function, it's basically a helper function, and all it does, as you can see in the comment, it runs a check to see if the player is currently moving at all, right? Because in order to do head bobbing, we want to do head bobbing when the player is moving. So it's very important to be able to check if the player is moving. So this function basically takes the character movement, it does some simple math to figure out the velocity, map it to a new range, round it off, and then we do a check over here, and we check if the velocity of the player is greater than 0, then that means that the player is moving, and we have a custom variable here, a boolean that turns to true. If the velocity is 0, right, the player's not moving, this becomes false, and we set the moving variable to false. And then we output it through this return node, which means that we have access to it right here, right? And we can pull this boolean out and connect it to something. That something is this function right here called headbobbing. So if we dig into this headbobbing function, it's a little bit messy. I haven't organized this or cleaned it up, but basically we get this should head bob. So when should we head bob? We should head bob when the player's moving. So we already figured out, a step ago, if the player's moving, and we do that by checking the player's velocity. If the player's velocity is greater than 0, the player's moving. If the player's velocity is 0, it means you're standing still in the same spot and you're not moving. Therefore, we don't do a head bob. So if it's true that the player's moving and we should head bob, we calculate the player velocity. Now, this is a little bit messy right now, but basically what this does is it takes the player's movement, does some simple math to figure out the velocity of the player, and then we return that value through this output node over here in this function, right? And you can see the comment says, calculates velocity / speed of player, useful for calculations, checks, etc., etc. And this is a redundant node. I don't need this node right here, but I was working really late and I was just trying to get this stuff to work. So over here we calculate the player velocity, and here it is. Here's the player speed, right? And we check the player speed. And if the player speed is less than or equal to 6, that means that the player's probably crouch walking, which if it's true, we stop any other head bobbing animations. And if we look at this, this is also a function. What this does is it goes through and it stops a camera shake of player head bobbing animations. And then what it does is it plays the player head bobbing animation. Now this doesn't say animation, it says client play camera shake. Why would you use a camera shake instead of an animation? Well, the camera shake node is pretty cool because it does more than just camera shake. You can use this node to play a procedural camera shake. For example, it's great if a grenade went off pretty close to us, didn't kill us, but the force of the explosion shakes our head in a first-person shooter game or a multiplayer shooter game, something like that. This works really well, okay? But the cool thing about the camera shake node that it's not evident right at the beginning up front. The camera shake node should also be called the camera animation node, or camera shake plus animation node or something like that, because you can use this to do all kinds of animation work with the player camera. All right, it's not apparent at first, but that's the case. And what you do is you plug in a shake class right here, camera shake. So if you go to the content browser and you right click and you go to create a new blueprint class, you can do a search down here for camera. And if you do that, you're going to see camera shake class down here. Okay, and if you read the tooltip, it gives you some more information. You can read that on your own time. I'm not going to go ahead and read all of that, but the main thing to remember is that the camera shake allows you to do two things. You can do oscillating shake, which is procedural shake. You just input some parameters and it'll procedurally create camera shake, and that's more random. That works great if, again, if the concussive force of an explosion made your player's camera shake a bit. A grenade goes off in a multiplayer game, that'd be perfect for that. But then at the bottom it says animated shakes, and that's what we're interested in. So let me cancel that. So when you create one of those camera shakes, you end up with an asset that looks like this. And you can open the full blueprint editor, but there's really no point. Most of the functionality you need is right here. So on the top, we have the oscillation parameters. And oscillation is procedural camera shake. That basically means, again, if an explosion goes off, this thing's going to shake your head for a bit, for whatever amount of duration you select over here. which is pretty cool. Works great, again, for explosions, or maybe if you're making a boxing game in first-person view and you get punched in the head, you play a little camera shake to make the player feel like, you know, they got shocked from getting punched in the head. Down here is the anim shake, and that's what I'm interested in. The anim shake lets you do more controlled camera shake, which is more of an animation, not so much of a shake. So what you can do is you can plug in a custom anim right here, a camera anim. That's the type of class it is. Right here I've got one called Headbobbing anim, and if I go look for that and I open it up, the class is camera anim. So to create one of these, you right click, go to miscellaneous, and at the very top right here, in at least in Unreal 4.12, you'll see camera anim, and if you create that, you'll get one of these guys. If you open this up, this might look familiar to those who have used Unreal Matinee before. It's basically like a matinee animation, and what you do is you come up here and you add a movement track, right? And what I did was I animated some movement and some rotation. Now my animation looks really bad right now because I'm prototyping. I'm just trying to get stuff in as fast as possible so we can prototype this game and get it going. Later on, when we get to polish, me or one of the other members of the team can come in here and create a more detailed head bobbing animation so that the game looks more polished and nicer. All right? Because if I jump into the game right now, I got head bobbing, but it doesn't look that great. I mean, it's there and it works, but if you're a professional animator and you look at this, this doesn't look very good. It's not very detailed. It just doesn't look great. I can tell you that right off the bat. But at least the functionality is there in the prototype, and then later on, all I have to do, me or someone else on the team, can go into that camera anim and sit here, for a whole night or a couple of hours and do a really high detailed, really nice camera head bobbing animation. And then when that animation's done, you just go to your camera shake class, which again, go to the content browser. I have 3 of them. I have one called crouch walk, one called run, which is the sprint, and one called walk. And every single one of these uses the same head bobbing animation. And the cool thing is, you can come over here to the play rate, and you can take this anim play rate and you can set it to whatever you want. So if you want the animation to play faster during the sprint, all you do is take the head bobbing run, right? Plug in your animation, take the play rate and increase it. The default is 1, which is normal. If you set 3, that means the animation is going to play, 3 times faster. So it'll look like you're sprinting, right? Essentially, you'll want to create some really nice animations so that the sprinting or running animation will have its own sort of unique look and feel. And then the walking will have its own unique look and feel, and then the crouch walk will have its own. That's the best way to do it, but that's for polish. When you're prototyping, you don't want to care about those things. It's a big waste of time to do that. You just want to get stuff up and running. So that's pretty much it. There's a few more parameters here. I'll let you kind of discover those on your own. Not going to go through all of them. But those are kind of the important things about that. So as you can see here, back in Blueprint, and this is a little bit messy. I'm going to come in later and clean this stuff up, polish it up. But right now this Blueprint is kind of messy. I was just kind of, shooting from the hip, so to speak, and just getting this stuff up and running because I had to prove it out. So basically what this says is if we're head bobbing, that's true, calculate the player's velocity. If the player's velocity is less than or equal to 6, which is about the velocity of the player when they're crouch walking, then stop all other head bobbing animations and play the crouch walking animation, which is this one right here. Okay? Now, if the player's velocity wasn't less than or equal to 6, then we check and we see, is it less than or equal to 25? Sorry, I couldn't even read my own number. If it is, then we stop all head bobbing animations and we play the walking animation, because that's the speed at which the walking animation should take over. But if that's false, meaning that we're going faster than 25, that probably means that the player's booking it and trying to escape from a monster or a ghost or something, and are trying to sprint down the hallways of this train, the spooky ghost train. In which case, we stop all head bobbing animations and we play the head bobbing run animation. See that? And again, this is kind of messy. I'm going to simplify this and clean this code up a bit later. Not going to worry about it now. I just wanted to get everything up and running and working. So to test the player speed, here's what I can do. I'm going to grab an event tick. I'm going to grab my calculate player velocity function. This is an awesome function, by the way. And there's the player speed. So what I can do is I can create a print node. And we're going to take the speed and hook it up to that guy right there. And what this will do is at all times, I'm going to get a readout on the player's velocity. And this will make a lot of sense in a moment. Just check this file out. Play an editor. You can see on the left, I have a velocity of 0.0 because I am not moving and standing still. But if I start walking, my velocity goes up to 25, right? So that's walking speed. If I crouch walk, my velocity is a maximum of 6. So between 0 and 6, I'm crouch walking, right? If I stand back up again, I'm walking normal speed. So between 6 and 25 is walking normal speed. And if I hold down the run key, which is shift on the keyboard, it'll go from 25 to 100, so that means that I'm sprinting. So that'll work even if I have a gamepad, because you know, with a gamepad you can push the stick a little bit forward or a lot forward, and you'll get in between speeds. On a keyboard, you know, if you hit the W key to walk forward, it's just going to be like a set movement. But if you have a joystick on a gamepad, like a Steam controller or an Xbox gamepad or a PS4 controller, then you can control how fast you go, which is pretty cool. Okay. And again, the way I get that velocity is through this function right here, where I get the player's movement, I get the velocity, I find a dot product, I do a map range, remap it, round it off, and then I get my player speed. Pretty basic, simple math. And I am not a math wizard at all. I'm actually extremely bad at math. But sometimes I need it for game development, so I force myself to learn it or to figure it out. Okay, cool. So that's pretty much it. That's all I have really to show for this Dev Diary video. Pretty cool stuff. I like the way it ended up. Again, it's not polished, but we're prototyping this game right now, so no need to worry about polishing and making stuff look perfect. If you're creating a game and you're trying to make stuff look perfect before you finish building the whole game, you have a problem. You need to stop what you're doing. You need to go back and you need to rethink some things, because you're never going to finish your game if you try to do polish as you prototype. So prototype first, prove your concept out. When it's good to go, then you polish. Okay? Alright, cool. So that's pretty much it. I'll see you guys in the next Dev Diary video, where I have no idea what I'm going to do next, but I'm sure it'll be something interesting.